Hello.
Yes.
So we're going to do past questions.
Yes.
Or separate.
Are you there?
Yes, sir.
Okay. So let's look at these.
Hi.
Yeah.
I'm not going to be the time. How far? Oh, you thought so?
Yeah. Okay. So let's start. Let's look at some past questions. Okay, just give me a small minute so that I will let me share my screen. Okay. Download. Chemistry 1. Yeah, so I'm gonna share my screen now.
Okay.
So that we can see some questions in separating techniques so that we can.
Okay. Okay. The class, how to organize the class. So you're fine. Only me. Tutorial class.
Yeah, how are you?
I'm good.
Okay, so are we seeing my screen?
Yes.
Okay, can we see these chemistry questions?
Yes. Yes.
So it says, Suleiman, come on, lock it from outside, please. See the key. Just hold it out, pick up,
Okay. Where will I put it?
throw it inside. Okay, can you see this question? Jamb 2020 chemistry. Which of the following procedures will separate a mixture of sand, sodium chloride,
Sodium
iodine into its
chloride
can you
into it. Yes.
class? Can you see that question? Is
Yes.
it very clear?
Yes.
Okay, so you can actually get it down. Let's sort out this problem one by one. So the
Okay.
question goes, which of the following procedure will separate a mixture of sand, sodium chloride, and iodine into its components? So number one option is to add water. Then there will be a sublimation action, then filter, then evaporate to dryness.
Dryness.
Then number two option will be to add water, then filter, then sublime, then evaporate. And the third option is sublime, filter, add water, evaporate. And the fourth is sublime, add water, filter, and evaporate. Who can give it a try? Who can give it a try? Who can give this a try? Please, are we still together?
Yes.
Okay.
Yes.
Can we see the question on the
Yes.
screen?
Yes.
Okay. Good. So how can we separate these? You have a mixture of sand. Sand is an insoluble solid.
Yes.
Sodium chloride is a
It's a
soluble
soluble solid.
solid. Good. Then iodine is a substance that can sublime.
Yes.
Understand? So if you
Yeah.
have the three of them mixed together, so how do you separate? So number one, if you want to get to understanding, number one, you need to know that iodine in the mixture can be gotten by sublimation.
Sublimation.
So it can actually turn from gas directly to solid. So sublimation, water will be added. If you add water to a solution to a sodium chloride and sand, what do you expect to happen? Sodium chloride is going to dissolve in the water, isn't it? Because
Yes.
sodium chloride is soluble. Abi?
Yes. Yes.
So which is soluble in water, so it will dissolve. Now the mixture of sodium chloride solution and sand. Sodium chloride solution is a soluble solid in water. Now you have it mixed with sand, which is insoluble. How do you separate? You can use filtration to separate them using a filter paper. Because once you pour the solution of sodium chloride solution, water will be left on the filter paper.
Yes.
Then
Yes.
the sodium chloride solution will go through.
Yes.
Now the sand will be gotten as a residue, while the sodium chloride will be filtered. So
Yes.
lastly, what you're supposed to do in order to get your sodium chloride will now be to do or heat it. When you heat it, the water will evaporate.
Yes.
Good. So the process that this will take is by number one, there has to be sublimation.
Sublime and add water, filter, evaporate to dryness. Yes.
Perfect.
Yeah.
So that's the answer. So because the first thing that we'll have to do is that the sublime,
Yes.
the substance that can sublime has to go.
Yes.
Which is the iodine, isn't it?
Yes.
Then after the it has gone, you cannot add water before you sublime because water will disturb this. That's why the sublimation has to go first.
Yes.
Then you add water. So when you now add water, you'll be able to separate the sand from the sodium chloride solution.
Yes.
So when you add water, you filter, the sand goes out. Then you evaporate to take out the water so that you have your sodium chloride solution. Are we together on this?
Yes. Yes.
Okay. So very importantly, we need to understand how the question comes. We need to understand how the question comes. This is how it's going to come. Which of the following procedure will separate a mixture of sand,
Sodium chloride, iodine
yes,
to its component.
yes. Okay.
Yeah.
Do we move forward?
Yes.
Okay. So moving forward, let's look at this other question. This is Jamb 2020-19. So components of ink. How can you separate components of ink? I told us that anything that has color, that you can separate them using what? What did you say about separating color? Chromatography. Good. That's how you separate. Good. That's how you separate anything that has color. It has to be via chromatography. What of water and kerosene?
Separating funnel.
Good. You can use separating funnel because water and kerosene, two of them are immiscible. Abi?
Yes.
So whenever you're having immiscible liquids, you separate immiscible liquids using separating funnel. So when you mix the two of them, the one with bigger density is going to be below. The one with lesser density is going to be up.
Yes.
Isn't it?
Yes, sir.
So the one with bigger density goes out there, remaining the other. So you can separate two immiscible liquids using separating funnel. But if the liquids are miscible, you have to use fractional distillation if they are miscible and their boiling points are very close.
Okay.
Now, how do you separate iodine from sodium chloride? This is what we looked at in the first example, isn't it?
Yes.
So you use what?
Sublimation.
Then why are we using sublimation? Can you tell me why we use sublimation?
The reason is that water will be added so that sodium chloride, which is soluble in water, can dissolve.
No. When we are looking at iodine and sodium chloride, why should we use sublimation? We are using sublimation because iodine can sublime. Iodine can change straight from solid to gas.
Okay.
You understand? So
Yes, sir.
if you're looking at, if water is part of it, that's when you'll be talking about adding water.
Okay.
But yeah, you are talking about two solids. You're talking about
Iodine acid.
sodium chloride, which is actually soluble. So sublimation can happen for iodine, then you can have your sodium chloride. Okay.
Yes, sir.
Okay. So let's continue.
Okay.
I'll also put this slide up so that you can still check it out later. You can get it as a note so that you can always go through it. Okay. So in which of the above is the principle used correctly? Okay. So we have components of ink. So if you have these combination, components of ink, components of water and kerosene, then components of iodine and sodium chloride. So how can you best use this in order to have your separation? So as way of explanation, chromatography is used to separate mixture of solids using a solvent moving over an adsorbent medium, which we already explained this. It is widely used to separate color complexes. Color. Whenever you hear anything color, you talk about ink or dye, then just know that you're using chromatography.
Yes.
Are we clear on this?
Yes.
Okay. So separating funnel is used to separate a mixture of immiscible liquids. When I was talking about miscible liquids, we talked about fractional distillation, the one that you use for crude oil separation.
Yeah.
But if the liquids are immiscible, if they cannot be mixed together, if you can observe the difference whenever you bring them together, you talk about using separating funnel. Okay. So example of fluid that you can separate with separating funnel is when you have something like petrol and water. Have you ever seen a mixture of petrol and water before?
Yes.
No, sir.
You can see that they can be separate. You can see them separately. So you use
Oil,
what we call
oil and
separating.
water too.
Oil and water too, yes.
too.
Yes, oil and water is another example. So you can separate them using separating funnel.
Yes.
Water and kerosene. Water and kerosene is an example too.
Yes.
So it's mostly for polar and non-polar solvent. You can use them to get them out. So once they are not miscible, you use separating funnel. Very, very important. Whenever you talk about immiscible liquids, separating funnel is what you use. Because once you mix them together, you can see them separated as in two distinct layers. The lower dense liquid layer is tapped off first, then leaving the upper one, which is more denser. Okay?
Yes, sir.
So this is an example of what I'm trying to explain. Can you see this? This is what we call separating funnel. Chika, can you see this diagram?
Yes, sir. I've never seen it.
Good. This is what we call separating funnel. So we have two immiscible liquids. When you hear the word immiscible simply means both of them cannot be mixed together. So we have water and kerosene. So pour the two of them, mix them in a can and pour them into the separating funnel. Once you pour them, water, which is having more density, is going to be on the lower side, whereas kerosene, which is of lighter density, will be on the upper side. So once you open up this tap, all the water will go out first and be collected here, whereas the kerosene will be remaining here so that you can pour it out. Do we understand this?
Yes, sir.
Good. So this is what we call using separating funnel for your separation.
Excuse me, sir.
Then lastly, sublimation, like I said, one of the solids must be able to sublime. If one cannot sublime, then you cannot use sublimation. So if you have a mixture of iodine and sodium chloride, which of them sublimes? Who can tell me?
Iodine.
The iodine, good. So I hope this is clear.
Yes.
But I don't really still
Okay.
understand the first one.
Okay, you didn't understand which
Adding
one?
water, yes. Yeah, adding water, then
Adding
the
water.
filter.
Come again, please, check.
It's like, is the iodine not in gas after you sublime it? How will you add water in it?
No, this one, there's no need to add water at this point.
No,
You understand?
the first one that you sublime, add water, filter, and evaporate.
Okay.
Dryness.
He's
So
talking
the
about
one you
first.
added water is the first
Yes.
question. So
Yes.
why did we add water? Because there is sand. And we wanted to separate the sand from the sodium chloride. This is the question that we had to add water. This is the one that the answer was C. So we have a mixture of sand. Can you see this sand here, Chika?
Yes.
Good. Then you have sodium chloride, you have iodine. You understand? So first thing, if you want to separate this, the first thing you do is to sublime in order to take out this iodine. That's the first thing. So that's why you have to sublime first. Now, after the sublimation, you now have only sand and sodium chloride left. So this sand and sodium chloride that is left, in order for you to get them out, you need to add water first.
So that
Because when you add water, sodium chloride is soluble, whereas sand is not soluble. Are we clear on this?
Yes, sir.
Good. So when you add water, because one is not soluble, you use filtration to take out the one that is insoluble. So the sand will remain on as a residue, whereas the sodium chloride will go in with the water. So you now evaporate in order to separate the sodium chloride from the water that you've added. So that's how you can have your complete separation. Is that clear?
Yes, sir.
So quickly get down this note, so that we'll continue.
Yeah.
Okay. Should I move it a little bit up?
Yeah.
Yes, sir.
Okay.
Wow.
I should still go up.
No, sir, it's okay.
Yes, sir. Yes.
Okay. I just went up a little bit more.
Okay, okay.
I hope it's okay.
Yes, sir.
Yeah, once you want me to move to the next slide, let me know.
Okay, okay. You can move to it, sir.
Yeah. Okay, I think the best thing will be for me to keep going. Then maybe when I'm done, I can send this very material to your email.
Okay. Okay, sir.
Chika, what about you? Is that okay with you?
Yes, sir. I'm done.
Okay, you're also done. Okay. So let's look at another question. So this is the separating funnel. We looked at how this works, and let's look at one more separating technique problem. Okay, so we are here. We have chemistry 2016. Ammonium chloride can be separated from its mixture with common salt by. So how can we separate ammonium chloride from common salt? So we have option A, distillation, B, evaporation, C, decantation, D, sublimation. Now, ammonium chloride is a salt that can
I can't see
sublime.
the question.
Okay. Um, can you see the question now?
Yes.
Yes.
Okay. So the question says ammonium chloride, Jamb 2016 chemistry, number 12. Ammonium chloride can be separated from its mixture with common salt by A, distillation, B, evaporation, C, decantation, D, sublimation. So we have these options. So what should be the answer? Now we look at ammonium chloride is a salt that can sublime. So it can turn into gas directly. So I said before that when you hear the word sublime, sublime simply means a
Solid to gas.
solid that can move straight from solid to gas, good whenever you heat or even at normal temperature. Now, common
Yes.
salt, which is sodium chloride, cannot sublime. We all know sodium chloride, which is our salt, the
Yes.
salt we use in
Yes.
the house. Only that we know that it can dissolve in water because we use it to cook, but it cannot sublime.
Yes.
So, therefore, a mixture of ammonium chloride, which can sublime, and sodium chloride, which cannot sublime, can best be separated by what?
Sublimation.
Sublimation, isn't it?
Yes.
Yes, sir.
Yeah, that's the easier way. Because with sublimation, the ammonium chloride will just go, leaving out only the sodium chloride. Are
Yes.
we clear
Yes.
on that?
Yes, sir.
So this is an example of a setup where we have that. So we have your mixture here. So once you apply heat a little bit, the pure ammonium chloride will go, leaving off the sodium chloride. So take note of that. That's another way. So we can see from what we've done so far, what and what have you mentioned as things that can sublime? We
Iodine
mentioned good and what? Ammonium chloride so far, isn't
and
it?
chloride.
Yes, sir.
Are we together on those two?
Yes, sir.
Yes.
Okay. So let's quickly look at this physics and understand some concepts before we round up. Okay. So please, can you see my screen? And is it
Yes,
showing
sir.
physics?
Yes.
Is it physics that is showing? Okay.
Yes, sir.
Yes.
So we have the dimension of power is, we want to know the dimension of power. Is it MLT? So I want us to understand what dimension means. Whenever we're talking about dimension, we are talking about using the basic or fundamental units to represent the derived unit. You understand?
Yes, sir.
Taking
Yes, sir.
mass to be M. Taking mass to be M. So whenever you see M, M represents mass. L represents length. T represents
And
time.
tea time.
Isn't it? Was that
Yes, sir.
what we did yesterday, Chika? Did you consider those three fundamentals? Did I make mention of
Yes,
them
sir.
yesterday? Good. So whenever you're representing in this MLT, where M is mass, L is length, and T is
Time.
time, then you're talking about dimension. Okay.
Yes, sir.
Now, so let's take an instance of a derived quantity and turn it into these fundamental representations of dimension. So let's take an example of power, which is what the question is asking. It's asking us if you want to turn power into the dimensional representation, is it going to be this ML2 T3 minus 3 or ML2 T3 or ML? Is it which of these is it going to be? So we all know that power is equals to
Power is
work
going to work
done
over
over
time.
time. Are we aware of power being work over
Yes.
time?
Yes, sir.
Yes.
Okay. So knowing that power is work over time, then it's simply equal to work is the same as saying
Force
force
times
times
dimension
distance
over
moved.
time.
Good. So this time is still this time. Now, force is mass times acceleration, isn't it?
Yes. Time,
Good.
distance,
Then
over time.
distance is still this T here.
Yes,
T
over
is
time.
still T here. Now, how do you represent mass in dimensional way? You use capital letter what? M, isn't it?
Yes.
Isn't it?
Yes.
Yes, sir.
Good. Then what is acceleration? Is acceleration velocity over time? Is it velocity over time? Class, can you tell me whether acceleration is velocity over time?
Yes, sir.
Yes.
Good.
Yes.
Acceleration is velocity over time.
Over
So
time.
that's why in place of A here, we're having V
Represented
over
with
T.
V over T. Yes.
Isn't it?
Yes, sir.
Velocity over T, isn't it?
Yes, sir.
Then this D is still represented here, whereas this T is still here.
Yes.
So you can see how we moved from this to this, from this to this, and from this to this.
Yes.
So now we have the next thing that we need to change, because we just want to see only M, L, and T. That's what we are looking at. So when
Yes.
you're doing dimensional analysis, you just want to see only M, L, and T. So you keep changing anything that is not only M, L, and T, because M, L, and T are your basic quantities. So make sure you change everything. So what are we still having here that is not M, L, or T? What are we having here that is
We're
not M,
having
L, or
V
T?
and D. V and D.
V and D, good.
Yeah.
So V is velocity, and we know that velocity is distance over time.
Yes, sir.
So in place of this V, we can write D over T. And that's
Yes.
why we have this extra D now,
Yeah.
all over this extra T.
Yes.
T is only 2 here, but here it's 3 now,
Yes.
isn't it?
Yes, sir.
So that means we've removed V and represented it with
With
D over
D.
T.
Yes.
So now this is what we are having.
Yes.
And this can easily be changed into the fundamental dimensional quantities, where M is mass. Is M not mass?
Yes, M is mass.
So this is M, which is this mass. Then
Yes.
D is length. D is what?
Okay. Distance is
Length,
equal
because it's distance, isn't it?
equals to length.
So D is length. So how many D are we having?
2D. So making L
Good.
square.
That's why we have
L
L square,
square.
isn't it?
Yes.
Then we have how many
Triple T.
T's? One,
Triple T.
two,
So
three. How many?
T raised to power 3.
Good. That's why we have T raised to power
T raised
3.
to power 3.
So
Yes. So it's
good.
got
If
to
you now want to
ML2.
bring them on the same
ML2.
line,
Okay.
you have your ML2, ML
So
squared.
all over
Then
we now
T.
make this to be raised to power minus 3.
Good. Good. If it's coming up, it will be minus
Yes,
3,
yes,
and that's
it will
why this
change.
is the answer.
Yes.
So option A is
Okay.
the answer. Do we understand this dimensional
Yes,
analysis?
sir. Very well, sir.
Okay. Dimensional
Yes.
analysis is very, very important because it comes out almost every time in Jamb.
Okay.
So what you do in dimensional analysis is actually any quantity that is given to you, and in most cases they are going to be giving you a derived quantity. So change it into quantities that can let you represent them in the fundamental quantities of MLT. Is that clear?
Yes, sir.
So power, you need to know the definition of power. That power is work
It's
done
the ability
over
to
time.
do work. Yes.
Isn't it?
Yes, sir.
Then you need to know that work is force times distance. This time is already here. You put the time here. Then you need to know that force is mass times acceleration. So you still bring out the D here and the T here. Then you need to know that acceleration is equal to velocity over time. So in place of A, you're introducing V over T. Then you need to know that your V is what? Distance over time. So in place of this V, you're putting D over T. Then finally, you can convert all your D's, which are your distances, to length.
Yes.
And all your M, which are your masses, then all your T, which are your what? Times. So you represent them, and that is your dimensional analysis.
Okay, sir.
So when we solve more problem, we might get this more. Did you people copy?
Yes, sir. Yes, sir.
Copy is very clear.
Yes.
Okay.
Yes, sir.
Now, okay, so let's look at taking measurements from the measuring instruments. So we're going to look at taking a measurement from a micrometer screw gauge and taking one from a Veneer caliper. Are we clear on this?
Yes, sir.
Good. So whenever you're measuring using micrometer screw gauge or Veneer calipers, you focus on taking 2 readings. One will be from the main scale, and the other one will be from the Veneer scale.
Veneer
So
scale.
the main scale is always what you have here is your main scale, whereas the Veneer scale will be what you have on this other side. Are we clear on that?
Yes, sir.
So whenever you're giving this measurement, just check and see where the upper line is interfering with the down one. This diagram is not very clear, but in subsequent one, I will show you with a clearer one.
Clear.
But I want you
This
to
one
understand the
is a bit
concept.
clear. This one is a
Okay,
bit
it's
clear.
a bit clear. Okay.
Yes.
So on this four,
I could see
the
4.
upper one,
yes,
yeah, the upper one is
it's
coinciding
above
with
50.
the down one. Good. So that's why we take the main scale to be 4. Can you see that?
So it looks like as
Yes.
if the Veneer scale is before 15.
Is what?
Yes, it's above 15. Yes.
Okay, above. Oh.
It's above 15.
Good.
Yes.
So this
Above
one that is
15.
above 15 is 16 Abi. Is
Yes,
yes,
0.16.
yes.
Good.
Yes.
That's why you got this. So once you add the two of them, you have
It will
4.16.
give us
That's why
4.16.
4.16
Yes.
is the answer. Okay.
Yes.
Chika, is it
Yes,
okay
sir,
with you?
it is.
Good. So very importantly, once you take the measurement here, then you take the one here, you add them up. That's how you just get it. So anywhere it coincides here gives you this. So that's why 4 here. Then for this one, you look at this horizontal line. Where is it hitting this one? So you can see that it just slightly above 15, which is 0.16, and that's why we have this. Are we clear on this?
Yes, sir.
Yes, sir.
Okay, so let's look at this Jamb 2014 physics. What is the least possible error encountered when taking a measurement using a meter rule? So this is what we did yesterday. The accuracy for meter rule. What was the accuracy for meter rule?
0.1 centimeter.
Good. So you see your notes, Chika, you saw it. We did it yesterday, isn't it?
Yes, sir.
Good. So you can see that everything we did yesterday are exactly what is coming out here, because we are looking at your actual, what's it called? Your actual question. We don't want to waste time on plenty theories. We'll go to exactly what is likely going to come out. Can you see my screen?
Yes, sir.
Yes, sir.
Are you seeing meter rule is an instrument used to measure? Are you seeing it?
Yes, sir.
Good, good. So this is the answer to the question that is asking you what's the degree of accuracy for meter rule. So meter rule is an instrument used to measure length. It is graduated in centimeters and millimeters. The least graduation is 1 millimeter or 0.1 cm. Is that what you have in your notes?
Yes, sir.
Good. So we did that yesterday. So that is the accuracy to which meter rule can measure to. So this is measuring accuracy. So you can say it's 1.0 millimeter or 0.
Okay, so that is the answer.
Good, that is the answer. If it were to be a Veneer caliper, it would have been what? 0.1 mm or 0.01 cm, isn't it?
And yes, sir.
If you are to be a micrometer screw gauge, it will be what? 0.01 mm or what? 0.001 cm. Abi?
Yes, sir.
So micrometer screw gauge is more accurate than any all of them. Okay. It's more, you can use them to measure more minute distances. Okay. So let's look at taking the measurement of a Veneer caliper. Let's look at what? Taking the measurement of a what? Veneer caliper. Are we together on this?
Yes,
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 sir.
sir.
Okay. So this is what we are. This is similar to what you are likely going to see. So if you are asked what is the reading, so like I said, the reading is normally the main scale plus the Veneer scale. Is that what we said before?
Yeah.
Class, is that what we said before?
Yes, sir.
Okay. So the main scale, we'll check out where we have our, where there's a.
The Tclassified, is it the middle?
Yeah.
Okay, okay.
So
So we
we look
should
at
have like
where,
one. Okay, is that the middle?
yeah,
Okay.
you understand? So we have the main
Yeah.
scale is reading at 1.30.
Okay.
Okay, it actually depends on where we are reading from. So let's say our coincidence is here. If it is here, then this is gonna be what? What do you think if it is here?
Line of coincidence.
Yeah, if the line of coincidence is here, it will be above 1.5, isn't it?
Yeah,
And be
that's
around
1.6.
1.7.
1.7.
Yeah, 1.7. Abi?
Yes, sir.
So if it was to be here, then we are talking about 1.79. Abi?
Sir. Yes, sir.
Is it? But if we
Yes.
are taking our coincidence to be around here, then it will be around 1.39.
Yes.
Do we understand this?
Yes, sir. Yes,
So
sir.
I'm using this one question to take us like if we are having different scenarios, you understand?
Okay,
So we
sir.
have to check where coincidence is. In my next class, I'll be giving you diagrams that are very clear so that you can easily read out the coincidence. Are we
Okay,
together
sir.
on that?
Yes.
Okay, sir.
But
But
you
I don't
understand?
understand the solution for this question now.
Okay, for this question now, we are taking the coincidence to be at the back of this.
Okay.
Okay.
So, but the diagram is not showing actually that. So if it's at
Yes.
the back of this and we're having 1.3, then that's what we have here.
Okay, okay.
Are we together on that? But if
Yes,
we are
sir.
having above, then we're having 1.7. You understand? So
Yes.
I want us to take this question as if we are having this coincidence here and taking our answer to be 1.79 instead of 1.39. Are we clear on that?
Yes, sir.
Yeah. Most important thing is that you understand that is the point of coincidence where you pick your main scale, then you now check for the next one.
So how do you get the Veneer scale?
Okay. The Veneer scale now is once you get your main scale, then you read out how many points on this Veneer scale. Can you see your
Oh,
Veneer scale
the
here?
total
Can you
point
read?
is it the total point? Is it 1 centimeter? Sir?
Yeah, for what we're having here is 1.9.
Is
So if you read
yes.
out, can you read out this is 1, Abi? This is 2,
Two. Yes, 2,
3,
3,
you understand?
4,
Then when you count
yes,
it,
5, 6, 7, 8,
it
9.
gets
Okay,
to
yeah.
9.
What I'm
Chika, can you
asking is that
understand?
the total Veneer
Yes,
scale, is
sir.
it 1 centimeter?
Yes.
Okay.
That's 0.1 centimeter, not 1
Okay.
centimeter, 0.1 cm.
Okay. Thank you,
That's
sir.
for the total. You understand?
Yeah.
So from here
Yes.
you count. Then once you get to where the it coincides, that's when you stop, so that you can take out this reading.
So, sir, the
Are you
answer is
clear?
1.79.
Yeah, 1.79. That's considering this very point.
Okay.
Is it clear to you?
Yes, sir.
Okay. So can we move forward now?
Yes, sir.
Yeah.
Okay, so here we have which of the following dimensions of pressure Which of the following is the dimension of pressure? So pressure is equal to force over area, isn't it?
Yes.
Okay. So force is mass times acceleration, MA,
Yes.
just like we did in the other one, isn't it? So this is mass times acceleration. And mass is what?
Mass
And
times velocity over time.
acceleration is velocity over time, isn't it?
Yes.
So we have mass times
Velocity all over
velocity
time.
over time, which is acceleration. And velocity
Yes.
over time, we all know velocity is what? Length over time, isn't it?
Yes.
Good. So that's why we have this L over T.
Okay.
So this is representing velocity. And we already have our time here before. So we have our
Yes.
time, this very time. So we have ML over T into 2. So that's why we have
So to give us
ML.
MLT raised to power minus 2.
Good. Because of this, isn't it?
Yes.
But we know that we've not taken care of our area.
Area.
And what
Yes.
is area? Area is equal to what? Length times
Length
breadth, which
times
is
breadth.
good, which is double LL. So that's why we
Yes.
have L times L, which is L2.
L scan.
So if you take what is here and put this one under, then you have MLT to power minus 2, which is what we have.
Yes.
And this
All over
one
L
is
square.
good. This should be under it. That's why when you bring it up, it will be L to power minus 2. So it will give us ML minus 1 T minus 2. Who can tell me why we have this? This is L here, and this is L2.
Yes.
So one L will cancel one of these L. So it will
Okay.
remain just one L. And
Okay.
because this one L is under, if it's coming up, it should be what? Minus 1, isn't it?
Yes.
So that's why we have M L to power minus 1, T to
Yes.
power minus 2. Are we clear on that?
Yes,
Yes,
sir.
sir.
Okay, so take note of, you people understood the wahala we
Yes.
had here.
Yes, sir. Yes.
This should be 1.79. That should be the correct answer, except if you are considering any place behind here. And that
Okay.
is what will be clearer when I give you a better diagram. Okay?
Okay, sir. Yeah.
So subsequent diagrams I will be giving will have this very well stated so that you people can understand the reading. But I want you to understand that the reading is normally men's scale over what? Veneer, men's scale plus the Veneer scale. Is it?
Yes.
Okay. So I'm going to send these materials to your email. Please send me your emails on my WhatsApp so that I'll
Okay,
send this
sir.
material. Okay, I can even send it directly to your WhatsApp, Abi.
To the group, to the WhatsApp group.
Okay, to the WhatsApp so that you can check through it and
Yes.
understand
Yes,
better.
sir.
Okay.
Yeah.
So I hope it was a good class.
Very
Sir, not on
better.
the
It's a
WhatsApp
better
group.
class.
Okay. Yeah, I'll add you up to this group, Chika.
Okay.
All right.
Okay,
Thank
I
you,
can
sir.
also send it to you directly on your WhatsApp.
Yes, you
Okay.
can, sir. Just send it to me.
Okay, I'll send it to your WhatsApp. Okay.
Thank you, sir.
Yeah, so I hope it was worthwhile.
Yes,
Yes,
sir.
sir. Yes.
Yeah, we'll be continuing later.
Uh,
Thank you. God bless you. See you
sir,
when I see you.
I have a question, sir.
Okay.
Sir, please,
Can,
can you just scroll down?
Okay.
if you want to help me process OAU, how can I do it? Like,
Is it OAU admission?
yes.
Have you gone to their website to apply for their?
No, I haven't. I want to sit for Waec and Jamb this year.
Okay, you're a fresh student. Okay.
Yes.
What you do is that during the application, when you are applying for your JAMB, you pick OAU as your first choice.
Okay.
You understand?
And for computer science, what's their cutoff? I don't know about that.
If you're doing computer science, it's most likely you want to write. Are you writing maths?
Yes, maths, English, physics, and chemistry.
Good. So just make sure you're getting. You'll be aiming at 250 and above to be on the safe side. Okay.
Okay, sir. Okay, sir.
Yeah.
Yeah.
You're working
Thank
towards
you, sir.
250 and above so that you'll be on the safe side.
All right, sir.
Yeah. Thank you.
All right, sir.
Yeah.
Till
So we're
tomorrow,
gonna
sir.
sign up. Yeah. Till tomorrow. Thank you. God bless you. Yeah, bye.
Yeah.